All right, so saw the request. There was a major request for number 12 on page 223. And I don't want to do the problem that is for you guys' homework because I want you to try to apply the ideas that we discuss. Okay, so I don't want to take away the application of the ideas, that opportunity from you, because remember, you're going to have to do this on your own. So I am going to do something similar, maybe just kind of clue you in on some of the thoughts you might use. And it is going to be very, very similar, so at least you can try and practice one on your own with it when you do number 12. So the one that I've chosen, you can see here, is number 11 from page 223. Now, it looks kind of different than the one that you're asking about, but trust me, it's very similar. Now, the other thing that you need to know about number 11 and number 12 are that they're going to use those algebra tricks that I just discussed. Okay, the algebra tricks regarding exponents. Now, the other thing you need to know, I haven't done this problem ahead of time. So everything you're going to see here is kind of like on the spot. These are my thoughts. And I'm going to try to think everything out loud. Remember, don't pay attention to just the steps that I'm taking. It's not the steps that are going to help you. It's the thoughts that I'm taking. Okay? These are the thoughts that, if you can have thoughts similar to this, if we can use the problem-solving strategies we've talked about, you're going to be more successful on all these problems, not just this one. So the first thing I need to look at, I can see, is that I need to decide which side of this, the left or the right, are my pieces to my puzzle. What are the things that I'm going to play around with, and what am I trying to change this puzzle into? Now, if I look at this, this looks like a way prettier picture to me than this, which kind of would tell me that this is what the box of my puzzle looks like, and these are the pieces of my puzzle. These are the things that I'm going to use to construct and show that they're actually, the box that, the puzzle that says it's on the box, okay? So I'm going to take this stuff and I'm going to make it into that. All right, so that becomes my goal. How can I make this that? Goal. Now the first thing I notice right away, yeah, I'm not a big fan of these functions, cosecant, secant. I like sine and cosine better, but I'm not going to change it. And the reason that I'm not going to change it, and the reason I'm not going to create a subgoal right now, is because I realize that cosecant is there, and I already have it. Like, that's ideal for me. I already have something that I want in the end, so I'm going to leave that alone. Now, the only difference is, when you look at this problem, I have cosecant here. That's what I want, cosecant theta. But I have cosecant squared theta there. I don't want a squared. So, knowing what I know about exponents, I can actually take cosecant squared, and I only want it to the first power, so I'm going to kind of break that up. I'm going to rewrite it as cosecant theta times cosecant theta all over cotangent theta. And I know this because squared means multiplied by itself, so I just dissected or kind of factored, broke it up. Now what I look at, this actually became more like something I wanted. I got something I wanted out of it. So I kind of want to leave this alone. It's not part of my pretty picture. The only thing is it's still the numerator of this fraction. Matt, I realized, because I know how to work with fractions, that I just want to kind of pull it out so I can separate everything else and get it all by itself like my pretty picture in the end. So I'm just going to kind of pull this out front. And write everything else down. Now I know I can do this because I could theoretically put this over 1. And if I put this over 1 and multiplied it back out, I get back to exactly what I had before. So now, looking at this problem, I realize this is what I want. It's right there. Okay, this stuff has to somehow become this. Now the other thing I notice, I have 2 things that are multiplied here, and I have 2 things that are multiplied here. There's not really any difference there. Okay? I have a first power cosecant, so like I said, I'm going to leave that alone, and I have to somehow come up with that from here. Okay, so I'm not a big fan of this. I don't know exactly how to work with that. And I'm not a big fan of secant, so I'm going to go back to that idea. I need to know what the heck secant is. So what is secant? Well, this thing is really just 1 over cosine of theta. So this piece right here, that piece that I'm still trying to get in there, is 1 over cosine theta. So at least I know more like what it looks like. These things aren't in good function. I'm not a big fan of these functions. So I'm going to go ahead and change both of these as well. So I'm going to get my cosecant theta, which I'm leaving alone. That is, well, let's see, that's 1 over sine theta. That's cosecant theta. And you notice I'm putting a big fraction bar here just so I can see my numerator and my denominator kind of clearly. Cotangent theta, what the heck is cotangent theta? Well, that's the opposite of tangent. Tangent was sine over cosine, so this has to be cosine over sine. Again, if you memorized your trig identities, that's really going to help you here because you wouldn't have had to do any mental thoughts there whatsoever. So now that I look at this, that's an ugly, sloppy mess. But at least I've got things that I'm more familiar with, things that I'm used to working with. Maybe I can somehow make that, wait a second. Cosine's in there and cosine's in here. And heck, there's sine in there twice. Maybe somehow it's going to cancel out and I can get just that cosine and there's my 1. So this is very reminiscent of that. That's telling me, hey, I'm on the right track. You're on the right road to success. Okay, so I've got something that looks more like what I want, so it's good. Right? So I'm going to come back over here just so I have more room. And I'm just going to write down, I'm going to write down it higher. That way you can see it. Cosecant theta times 1 over sine theta all over cosine theta over sine theta. So that's what I have from over there, and I like to make that big fraction bar so I can see the numerator and the denominator clearly. Now if you look at this, I have a fraction on top of a fraction, which I'm not a big fan of. It makes it look ugly. I'd like to be able to take this and just take this fraction and divide it by that fraction. And if I remember back, most of you like this trick. You're going to take this denominator and you like to flip and multiply it because dividing by this is the same thing as multiplying by, the reciprocal of it. So I'm going to take, and I get this, 1 over sine theta. That's my numerator here. And I'm going to take and multiply it by the reciprocal of the denominator. I'm going to flip this denominator and multiply by that. So I'm going to end up multiplying by sine theta over cosine theta because that's the reciprocal of this. Now again, I should probably go back and check in my goal and make sure this is kind of coming out nicely. So what I see is, hey, cosine did end up in the denominator like I wanted, which is great. And I do see that this sine is now in the top and the bottom. It's going to end up canceling, and there's my 1. So I'm on the right track. I can still tell that. So then, coming down, I'm going to go ahead and multiply these fractions out. I end up with sine theta over sine theta cosine theta. And I'm showing all the algebra. Some of you might have skipped this step. That's okay. I'm just showing it for everybody who needs it. So what I see in here, I've got sine theta in the top, sine theta in the bottom. Everything that's occurring is multiplication. So I'm going to go ahead and be able to cancel stuff out. It's not like I have addition in there that's screwing everything up. So sine theta cancels out with sine theta. That really leaves me with just a 1 on the top. That 1 that you can always multiply by 1 because that doesn't change anything. Okay. So I end up with CSC of theta, cosecant of theta, times 1 over cosine of theta, which is what I wanted as my sub-goal, but I want to still say that that's equal to my goal. So in the end, I know that this is cosecant of theta times secant theta. And so I've shown, in the beginning, I started with this, and I've shown now that it's equal to this. And so I'm good. I'm done. So I hope this problem helps you with 12. Obviously we won't be able to do this again because I'm going to be back on Monday. So we'll go through some examples. You should be working on this stuff as homework. You should have almost all, basically 20 problems, I think is what I assigned. All 20 problems done, besides maybe a couple problems here or there that you just couldn't get. I understand there's going to be some hard ones and you're just not going to be able to get it. So do your best, okay? You should come maybe with a couple questions on Monday, but not too many. I'm going to assume that you've got most of this done. So good luck for the rest of the hour. I am going to give you the rest of the hour to work on these. Good luck. Talk in groups. Make sure you're getting help. And I'll see you on Monday.